Hello, everybody. So in the first part, we talked about how to get the Hamiltonian component and how to find the stationary states for this equation. Now we want to talk about the linearity solutions that we can get out of this. Well, we know that one of the solutions is simply our Hamiltonian multiplied by capital Phi. So something like this. And we know this is correct because that's what we start from, that's what we derived. And it means that anything that is equal to this, then it's going to be a solution as well. So let's say that in this case, our phi, capital Phi, in terms of x and t, is going to be equals to, let's say c1 plus phi 1 plus c2 capital Phi 2. Now you understand why I put the c at the end of the video. Anyway, so we're gonna have is equals to c1 and then little phi x, and then we have psi, and then the phi t, which is equals to, we said, e at the power of I e1, because we're talking about phi 1, psi 1, t over h bar, plus c2, then psi 2 in terms of x times e to the power of negative I e2 t over h bar. So if we take this and we plug it in, what do we get? Well, let's try it out. So we're gonna get I h bar in front, as always. That's not gonna change because we're not touching that. Now we're gonna have to plug in the new capital psi that we found. So we're gonna get, sorry, one sec. I think I got this mistaken. This was negative h squared over 2m. So negative h squared over 2m. This doesn't really change anything, but just to make it correct. So psi, derivative over psi, capital psi, which is little psi, terms of x, and then e the power of I e1t over h over dx squared. And we said that the second part of our equation is psi, I forgot the c1 in front, and psi 2 times c2, psi 2 e to the power of negative I e2 t over h bar, and then derivative in terms of x squared plus our v, which is multiplying our little psi x. Oops, I don't even need that in front. Actually, I don't need it. C1 psi 1 e to the power negative I e1 t over h bar plus c2 psi 2 x e to the power of negative I e2 t over h bar. And these are the same thing we said, right? Now, however, we can use the trick where we know that we can take these two derivatives in two different parts, because we can say that derivative of f plus g in terms of x is going to be equal to the derivative of f in terms of x plus the derivative of g in terms of x. So we can say this is equals to negative h bar squared over 2m, and then the first derivative, so derivative squared of c1 psi 1 x e power negative I e1 t over h bar over derivative squared plus the second derivative. So I'm just gonna do a little quicker. 2 and of course, sorry, actually this one is not inside the parentheses. The parentheses are over here. Okay, and and so we have plus, and then the second part remains the same. So we're saying that as long as this is a linear combination of these two, we are correct indeed in our calculations. So we can simply say that our capital psi is going to be equal, in terms of x and t, is going to be equal to this linear combination sigma of n times the phi n of x e at the power of, oh, cn in front, of course, e at the power of negative I e n t over h bar. Now, one thing that we have to think about, though, is that we need to have normalization. So our value, our psi, capital psi squared, has to be equals to 1. Well, let's try to work it out. So we have, for the first two, of course, we're going to have, it's going to be the multiplication between psi 1 and psi 2 plus, sorry, psi 1, and then psi 2 with psi 2, and then psi 1 with psi 2, and then it will be, actually no, that's kind of it. We can say this one is 0 because they are different, and then we get that psi 1, this one is like saying psi 1 squared plus psi 2, capital psi of course, squared, has to be equals to 1. So what do we get? Well, we're gonna get a c1 squared, and then the rest will be equals to 1, because of course we know that our function squared is equal to 1, so 1 plus c2 squared plus, sorry, times 1 again. I'm just taking the cn out of our equation, so the cn will be like part of this. I can actually prove it a little bit longer because it might be a little confusing. So psi 1 squared, I'm just going to do for psi 1 squared because of course the same thing for psi 2, is equals to c1 psi 1 x e to the power negative I e1 t for h bar squared. As you can see, I'm just taking this part out, so I'm gonna have c1 squared, and then again the rest will, which will be 1. Okay, so I get that c1 squared plus c2 squared has to be equals to 1, or I can say that the linear combination of all the cn squareds has to be equals to 1. And that's how we pretty much normalize our function. And we can use it in our expectation of h. So we know that it's going to be equals to, again, all the combination of n, and we can just say that it's going to be equals to the combination of cn squared en, with n equals to 1 going all the way to infinity. And this can be quickly proven if, for example, we were to go back and use our h inside our for our value. So we will get that is equals to the integral from 1, and then h1, and then we would have plus same value over there. Okay, 2 capital h bar 2, okay, dx. So we can take the capital H out. So we're gonna capital H out, or simply capital H out. Let's select that for now, and then this part remains the same times this part. Oh, this was supposed to be a capital, okay. And then again this part over here, sorry, and then this part. Wow, I didn't take the line, but okay. And we can take the cn's out, because that's going to be a different value. When we multiply these two, we're going to be equal to cn out, and then the rest will be equals to 1 plus, sorry, c1 for the first one and c2 for the second two. And so we get that h operator is equals to e. And so we get that the addition of c1 squared plus c2 squared times, we would have our h in front again, so is equals to e, is equals to our expectation value for h. And so if we just rewrite it, we'll just get the summation of n is equals to 1 to infinity is going to be equals to h. Okay, and then c of n squared and e of n. There we go. It's pretty straightforward, of course, once you know how to solve it, but the math isn't too complicated, and you can, as long as you understand the first part of this section, you will understand everything else pretty easily.